Hello, everyone. My name is Brad Hornback, and I'm the Associate Director of Community Management here at Patients Like Me. We're teaming up with the All of Us Research Program to bring you this webinar on genomics and the impact of individualized medicine. Today, I'm joined by Dr. Eric Topol, founder and director at Scripps Research Translational Institute, as well as patient advocate Christine Von Raesfeld, Patients Like Me Team of Advisors member, and All of Us Virtual Advisory Team member. We're excited to have an engaging discussion talking about genomics, why genomic data is important, and how to use genomic data to treat patients with a personalized approach. Christine and Dr. Topol, let's start with some quick introductions. Dr. Topol, can you kick things off for us?
Thanks, Brad. I'm the Scripps Research Director, founder of its Translational Institute. I'm also a practicing cardiologist and really into genomics for the last 20 years. I've been pushing hard on how we could take all that immense data and information and start using it in everyday care and prevention in patients.
So I'm Christine Von Raesfeld. I'm founder and CEO of a small nonprofit called People with Empathy. And I'm a patient myself. And I've found that my own data and my own research has been able to help me really tailor my own care and find out, how my future is going to play out for me. So I'm really fascinated with the aspect of genomics and where it can take us, and really looking forward to the innovation and therapies that are to come in the future for us all.
And we're so happy to have you both here with us today. And your backgrounds and the expertise that you both bring to this really makes it an exciting conversation. But before we get started, I'd like to ask Dr. Topol to explain in layman's terms what genomics is and why gathering genomic data is important.
Right. Well, just think that in every cell of our body, we've got our DNA code. It's got 3 billion letters. And for each DNA strand, there's 2 copies of that. So there's basically 6 billion letters. And any one of those letters can change. Or there can even be insertion of letters or deletion of letters. So that's what genomics is. It's about the letters. So instead of 0, 1, which is the binary code, it's as far as DNA, it's ACTG. But it's a similar thing. It's just basically that sequence of letters and how it is unique to each of us. And that's what makes us who we are. Of course, it's only one level, one dimension of who we are, but understanding our uniqueness is a very big part of getting our sequence, or even part of our sequence. So that's kind of why the field of genomics has blossomed over the past 20 years, because we've been able to sequence people's genomes at scale. And even if just using an array, which is just looking at a limited number of key letters, let's say 1 million out of this large amount, we can glean a lot of information. And so that's why it's become exciting, because it's now available in tens of millions of Americans, either the array data or even a so-called exome, which is the coding sequences of the genome, or a whole genome, which is basically the entire human genome sequence for that individual.
I love that focus on the uniqueness of each individual patient and how that can kind of tie into guiding the healthcare industry into more personalized care. And Christine, we'd love to hear the patient's perspective. Could you briefly share your experience with receiving personal genomic health information and how it has affected your health journey?
So when you talk about individual care, I'm one of those patients that is truly, one of those fascinating cases where pretty much anything and everything could go wrong. And throughout my life, my care has really been just a mystery, and it's been difficult to understand and difficult to interpret. But a few years ago, I was actually given an opportunity to be a part of the Stanford Human-Wide program, which gave me some of my genomic data way back when. And I was actually able to really tailor my future care and my treatments and the way that I was treated in a more personalized way. So we were able to find new conditions because of the data that we were collecting. we were able to really come to conclusions as to why things had gone wrong. We had done a pharmacogenomics test, which really helped me determine what compounds were difficult for my body to metabolize. And so we were able to find out why damage was done with certain medications. We were able to, again, tailor my treatments in the future to not include some of these compounds or to adjust them to me. And so it's really given me this opportunity as a person dealing with multiple conditions to have that individualized care that really does benefit me.
Christine, you've already touched on this a little bit with your response, but I'm curious from the perspective of both of, from both of your perspectives about how a provider can use genomic data to treat individual patients. Christine, if you want to talk a little bit more about that, and then Dr. Topol, from what is the experience like providing this data when you get it as a doctor and you're integrating it into the overall treatment?
Sure. So for me, it really has been a way to really get that care that really does affect only me. One of my conditions is lupus. And what we like to tell lupus patients all the time is that every lupus patient is different. We metabolize drugs differently, we react differently. And I think with precision medicine, we have that chance and that opportunity to really find out how an individual is different and really in the future tailor those treatments. So I think there's so much information out there that we could gather and collect that could be really helpful. But again, it depends on what that data is. We have to really be knowledgeable about what we're collecting, what we want to know, and really our end goals. But I think with the technology that we have, with the data and the opportunities that we have, there is truly a chance for us to change care for the individual.
So for me, as a cardiologist, most of our patients come in either taking a statin medicine or there's a question, should they take one? Some people are taking them unnecessarily, and a lot of people aren't taking because they don't know they're at risk for heart disease. And what we've learned over the recent years is that the traditional risk factors that we use, like diabetes and smoking and family history, are insufficient to make the call. And it turns out when you get your genomic risk score, which you can get for very inexpensively, and it's just 1 million of those letters, we can determine very quickly whether not only do you have a risk for heart disease, but also whether you should take a statin or not. So that's really great, because why would you take a medicine all your life where you don't need it? And what if you didn't know? I mean, it even happened to me. I didn't have any family history of heart disease. I got a genetic risk score, it was 96 out of 100. I started taking a statin. So it couldn't be more personal than that. But that's just the beginning of where this will go. And we're not even using that clinically. That these polygenic risk scores, without having to get a whole genome sequence, they exist for things like atrial fibrillation, type 2 diabetes, inflammatory bowel disease, various cancers like colon cancer, breast cancer, prostate cancer. We're not using this data, but we should. And ultimately, like with Christine, we would say, oh, well, she's genomically predisposed to lupus, and we're going to prevent that from ever happening before she gets that condition. That's where it can help take us in the years ahead. And it wouldn't just be our DNA, it could be also looking at our RNA, our gut microbiome, which is an important part, a mediator of things, and our environment and our sensors and all these other layers of data. So I don't want to make anyone think that DNA is truly the secret of life, because it isn't. It's just a very important part of it.
Can I touch on that as well, too? I think that, the technology and everything, that is a great thing to have, the digital therapies, everything that we have contributing data, but we really do need humans and that human touch still to interpret some of these things and to really give a person that personalized treatment that they need. But I think too that combined data can help us predict things for patient populations and predict risks for people, and also really help us in the end save some costs as well, because there's so much damage that occurs when we're giving people medications that they really don't need or shouldn't have. And so maybe you know, altering a few of those little things can really change things for people in general.
Yes.
You know, we work very closely with the Rady Hospital here in San Diego, the Children's Hospital, and they have a program of rapid whole genome sequencing for sick babies. And these are babies where the condition for causing why they're so sick is unknown, and they can take the whole genome sequence and crack the case in less than 13 hours and come up with a way to prevent brain damage, prevent death. I mean, it's just incredible. So that is another, I would say, exemplar of what you can do that is unknown diseases, undiagnosed conditions, even in adults, it can be made through genome sequencing.
Oh, that's truly incredible that all that information in such a short amount of time now can just be taken and processed, and we can pull so much out of it. And building off of that, and you've both touched on this a little bit, but I'd like to hear a little bit more about what you each see as some of the benefits or risks that could come from receiving this type of information. Dr. Topol, do any pros? I'm sure, well, many pros do, but what are the cons? What are the pros? How do those kind of balance each other as we're trying to figure all of this out?
Well, there's uncertainties that people have to understand, and a lot of times that's not appreciated. You know, there's gray zones. There's very few genes that are deterministic. The variants that you're going to get this condition. You know, very few. More, it's like, hey, if you alter your lifestyle or this or that, you know, you have a risk, but it doesn't mean you're going to get it. So it can lead to a lot of unnecessary worry if you don't have that context. We don't have laws in the United States to protect people from their data being used by insurance companies, particularly disability insurance is another example. We have what's called the GINA, you know, the Genomics Information Non-Discrimination Act, but it only covers part of the whole. It doesn't, like your employer doesn't cover that, your health insurance. So we don't protect people in this country from having that data, and that's why people don't want to have it in their chart, which they shouldn't, because it could be used in a you know, adverse way. So, you know, it's I think really important data, but we have not adjusted in terms of our policies to protect that information for each person, and that's one of the things that's holding us back.
I would agree with you on that. I think that we really need to educate populations around data and around the value of that collective data. I think as patients, a lot of us, sometimes we think individual data doesn't really mean anything. And if we're looking at the bigger picture and the grander scale, we need that data from all of these patients really combined to find solutions for us all. And so I think there needs to be a lot, again, education around data, around what it is, around, like you said, laws and regulatory things that are going to come up from this, because I think this is a bigger issue than we all really think it is. This is the new data economy coming up and supposed to be one of the largest or the largest distribution of wealth ever. And so how do you educate people on this data and make sure that they know the value of that collective data and how it can help not only them individually, but the general population as well?
It's incredibly important, you know, that the education around data, and we hear about data all the time for all different areas, all different things, but it means different things in different places. There's different levels to it. There's different levels of security, and there's different things to know. So having that education really is key. And it's always important to think about all sides of it. And I think not only is that about data, but it's also about bringing up the topic of genomics in the first place. From a patient perspective and from a provider perspective, how do you each advocate for genomic medicine in healthcare?
Well, you know, I think it's tricky now because we're just not ready for it. So it's now, let's say you have cancer and you happen to go to a lights on oncologist and they push to get genome sequencing of the tumor of your DNA and trying to help match up what is the best treatment. That would be one way you get into the genomics world. But that partly relies on connecting with the right doctor and facilities. If you have an unknown diagnosis, you may be able to find a doctor who also will initiate the process instead of going through what's often called the diagnostic odyssey with workups at multiple medical centers, which can cost ridiculous amounts of money and time and inconvenience. If you go right straight to genomics early in the process, that can make a huge difference. But really the most common thing would be, getting back to Christine's point, is about how these very inexpensive polygenic risk scores, which should be abundantly available, I actually think they should be made available for everyone for a nominal amount, like a few dollars or less, for free, because it has straight preventive value for medications, for assessing risk, so that people can, let's say you have a risk for the heart arrhythmia, atrial fibrillation. And that's actually quite important genomically to help gauge that risk. And you're overweight and you don't want to have atrial fibrillation because you might have a risk of stroke. Well, it might help people lose weight. So, or no less alcohol binging, which can also be a trigger for atrial fibrillation. So these are just some examples. If you know this stuff, it can help you in managing your health, to preserve your health, or that of your children or family members.
Well, I think I love what you were saying there, Eric. And I think there's so many things around data that we really need to explore and educate people around. And I think, the idea of collective data is one that I think many patients don't realize and don't talk about. And I think that's a huge thing when we're looking at really diseases, and especially rare diseases as we move forward. We need collective data from individuals to really help us go to anywhere. But I do also see a lot of things coming up where, I have a rare genetic condition myself, passed from parent to child. And when we found out about my condition, it's a heart failure condition, we also came across my family who didn't want to know. And I think as we move into this space, we also have to look at those people who may not want to know these risks, and how do we, as people who are wanting to know this information, are we putting other people at risk by us identifying ourselves? And I think, even things like life insurance, people don't think about that before they get this testing done. And I think that's one of the things we have to consider as well, is when you get into this, when you're moving into this space around data, is to really prepare yourself for what's coming, and how to protect yourself as well. So I think it's an interesting road that we're about to embark on, and I may have a different viewpoint of it. I grew up in Silicon Valley, and so I've seen these things develop. I have a different idea of data, but for the most part, I find that it's hard for people to understand something that's not tangible to them.
And the idea of collective data is something that's really close to us at Patients Like Me. That's something that we're all about, is people being able to share their experiences so that others who have the same condition or have symptoms for a condition can come and take a look at those different things. So this just kind of takes that more steps further beyond where we're at now, so that we can look at this at that individual level and how it benefits not just the individual, but it benefits everybody in the situation. And the last question I have is for Dr. Topol. Can you please explain how genomic information will be used in the All of Us research program, and what participants can expect to receive if someone donates a biosample?
Right. Well, that's, I think, one of the really exciting parts of All of Us, is that whole genome sequence ultimately first passes the arrays, the first cut of 1 million or more of these so-called letters, or SNPs as they're known, for single nucleotide polymorphisms, a fancy name. But that data will be provided to every participant who provides a biosample. And why that's great is, not only is that something that's provided, but what does the information tell that person, and what can they learn? And then we're always filling in the blanks. So right now, if you have a whole genome sequence with those billions of letters, there's still a lot of those that we don't know what it means. So over the years, as a participant in All of Us, there'll be updates. There'll be more and more knowledge that's imparted by having that information. So that's what the whole program is about citizen scientists learning about themselves. And the genomics is a dimension that really is kind of the best emblematic side of all of us, because it's a learning experience about, each person. And it's something that we hope will reshape medicine of the future. So the participants in the program are really the leaders of a new medicine going forward.
Can I tell you too that I love that you use the word citizen science? Because I think for me, myself, as a kid, I didn't see any need to study science. I didn't want to study science. But as I got older and I saw that these things could actually be applied and change my own quality of life, I started to pay interest. And so I think, to really know that there is a chance for someone as a scientist themselves to find out what may be bothering them that someone else can't find out is a huge, honor and asset to be able to have that here and to be able to do that for ourselves. So I think with what's coming, I'm just really excited about that citizen scientist role that's coming.
Citizen scientist really is a great way to phrase it. It's a great way to say it. And it's really exciting that there's this opportunity to participate and to change the face of medicine moving forward, to be involved, to educate people on why it's important, to kind of take charge and to be a part of that process. And that's what all of us really means, and that we all can be a part of it and take on that role of being a citizen scientist. We're so thankful to have had both of you here with us today to share your expert and patient experiences with us. It's been truly enlightening. Any parting words that you have for the people watching?
Well, for me, I just enjoyed the chance to meet Christine and hear her thoughts, and Brad, to connect with you and the folks at Patients Like Me, which a group I've admired over the years. It's really partly what shaped the book I wrote, The Patient Will See You Now, and how we really need to have patient-centered medicine rather than the talk. We got to walk the walk of it, and we're not doing that. And we have a long ways to go, but at least all of us and Patients Like Me, our collective move towards citizen science, these are all important ways that we'll get there eventually.
And I want to say thank you to both of you for having me on. And really, I am just excited for the future and to really see what our future can bring us. I see, just an amazing place for all of us. And like I always say, it's through the collective intelligence and collaborative leadership that will find viable solutions for us all. And so I thank both of you for just really engaging the patients in both Patients Like Me and the All of Us program. And I'm happy to be a part of both of them.
Thank you so much to both of you for all of the work that you're doing, for being here today and sharing all of these details with us. To all of our viewers at home, if you're interested in learning more about genomics or joining the All of Us research program, please visit joinallofus.org/patients for more information. Thank you for watching.